Alright, so in these videos I'm going to work through some problems. So what I did is I went through the homework problems and I looked at them and I said, okay, well, let me do some problems that are sort of like the homework problems and make sure that I get some good coverage of the topics in this unit so that you can see examples of actually how to do them. So the first problem I'm going to work is problem 17.2 from the book. So it says, given the data in this table that I've copied down here, it says determine the mean, the standard deviation, the variance, the coefficient of variation, the 90% confidence interval from the mean, construct a histogram, use a range from 26 to 32 with increments of 0.5, assuming the distribution is normal and that your estimated standard deviation is valid. Compute the range that encompasses the 68% of the readings. Determine whether this is a valid estimate for the data in this problem, and then I'm gonna give you a little bonus, and I'm gonna visualize this as we go through. So let's just start out here, and I'm going to use MATLAB for this problem because that's my favorite tool to work with. So I'm just going to switch over to this. I've started a MATLAB script here. So all I did here as the first thing is I just copied in the data. So this is our Y data, just copied straight from the book. I could have made an error, but hopefully I didn't. And then the next thing I do is I set n is equal to the length of Y. That's just for convenience later, because we're gonna use the number of data points in some of the other computations. So the next thing that I do is I set x equal to 1 to n, and I do this because I'm gonna plot it out. I'm gonna plot out y on a horizontal axis because that's the way I like to visualize it. So anyway, let's get to the first part of the question. The first part of the question asks, find the mean. Well, this is actually pretty easy. You just say y bar. I'm calling the mean y bar, and that's equal to mean y. This is the function that you use in MATLAB, and so that's just all there is to it. The next part, and we'll go over and actually look at the output in a minute. The next part is find the standard deviation of y. So that's just STD of y, and it's that easy. After that, part C tells us to find the variance of y, and we can actually do that just with the variance function var y, and that's all we have to do. Next, it asks us to find the coefficient of variation. The coefficient of variation, we didn't really talk about it a lot, but it's listed on page 443 of the book. It's just equal to the standard deviation divided by the mean. So just put that in here, and that's all we have to do to compute the coefficient of variation. And part E. Okay, so this is probably one of the trickiest parts. This is also explained how you do this is also explained in the prologue part of the chapter. This part is on pages 446 and 447 of the book, and it says compute the 90% confidence interval for the mean. So the first thing we have to do is realize, well, 90% confidence interval. What that means is if we have our distribution, if we had a standard distribution and we're looking at the 90% confidence interval, then we're going to have 10% that's not covered, and there's going to be 5% below, so I've written that here, and 95% above. So anything below 0.05 and above 0.95 is going to be outside of that confidence interval. And so to compute the confidence interval for the mean, the first step is to figure out this critical value. This critical value is, there's a lot of different ways you can compute it. Normally in statistics classes you'll get a table of values and you'll look it up in a table, and I think with computing packages tables of values are sort of outdated, and so we can use this function norm inv in MATLAB to find the confidence interval. Here I'm saying that I'm finding the confidence interval of a normal distribution because that's where I'm using norm inv, and it's going to have the distribution that I'm using has a 0 mean and standard deviation of 1. That's the z distribution that I've specified here. And then, as I stated, I'm giving it the confidence intervals, or the interval that I want to find it on, and so it gives it to me. It gives me those values, the critical p-values, and so then once I have those critical p-values, I can compute the confidence interval by just taking y bar and adding it in to the critical p-values. We're going to have one of them is going to be negative, and the other is going to be positive, and so these will already, if I just add them both to the critical p-values, then it'll be correct because they already have the sign attached with them, and anyway, so then I multiply that by the standard deviation divided by the square root of n. Again, the equation for this is in the book. This part of it is actually on page 448. So that's how you do the confidence interval for the mean. And then in part F, it asks you to plot out a histogram. And what it asks us to do, we can just switch back over to here to see. It asks us to construct a histogram using a range from 26 to 32 with increments of 0.5. Well, so when MATLAB plots out a histogram with the hist command, it centers the histogram segments where on the spots that you specify. So if we're going to use increments of 0.5 and it's going to center them, then we want our first one to be at 26.25, centered at 26.25 so that it goes 0.25 below and 0.25 above, so then we're going from 26 to 26.5, which is where we want the first one, if that makes sense. And then the last one will be at 31.75 is where it'll be centered, and it'll go up to 32 and down to 31.5. So when we specify that here, then we say hist y, that's just our data, and then we go 26.25, 0.5, that's how big the bins are, to 31.75. And that's all there is to it, to plot the histogram. Then in part G, it says, assuming that the distribution is normal and that your estimate of the standard deviation is valid, compute the range of values that encompasses 68% of the readings. Well, the first thing we have to realize is 68% of the readings, well, that's actually just one standard deviation, because if we sum between -1 standard deviation and +1 standard deviation and take the area under the curve there, that's going to be about 68%. So we'll just plot out one standard deviation above and below the mean for that. And then we need to determine whether this is a valid estimate. So here's the one standard deviation above and below the mean, below and above. And then it says, is it accurate? Well, so I'm going to figure out if it's accurate by looking at how many values are within the range, and then computing a percentage off of that. So I can get the one number within just by saying, well, take all the y's. This is what this does. Y parentheses, and take all of them that are bigger than RL. So that was our lower limit. Y bar minus S. That was our lower limit. So if they're greater than the lower limit and they're below the upper limit, that's this part here, then let's pick them. And so that this command gets all the y's, and then if we want to know the percent within, then we can just figure out how many y's there are in there. So that's just the length of that vector. So length within, and then we divide it by n. We divide it by the total number, and that'll give us a percentage. Well, we'd have to times it by 100 to get a percentage, but we can just observe that and get that. Okay, and then we're going to visualize it. So let me just start the visualization and go through the parts here one by one. And the script I had was called problem 17.2. So let me just pull this figure to where you can see it a little better. Make it bigger. Okay, excellent. All right, so the first thing is to just plot out all the data points, and this is what they look like. I have the x's on this axis, and I just created the x's. They may come with x's, and they may think that x's aren't important, but sometimes x's can be important. So I just arbitrarily assigned them the x's to the data points as they give us in order. Okay, and then the mean. So I computed the mean. The mean was, we can flip over here to MATLAB and see what the mean was, because it just ran all that and output it. And so the mean was 28.025. And so if we look here, 28.025, that's the mean that we plotted out there. The next thing is the 90% confidence interval. So for the mean, the 90% confidence interval for the mean was our confidence interval right here, 27.68 and 28.36. And so plotting that out, that's our confidence interval for the mean. The next thing that we were looking at is one standard deviation above and below the mean to get 68, the 68%. Oh, no, before that we had the histogram. And so here's what the histogram of the data looks like. And rather than using the command I showed you, well, I did use that command, but then I also flipped it sideways here so you could see, because the data is distributed like this, so you can see this should reflect the data here. There are more data points on the bottom than there are above. There's just one data point up here that's represented by this bar, and so you see the histogram. Okay, and then we're going to plot out the one standard deviation above and below, and that's given by these two green lines, and that's I think, yeah, that's pretty much it for this problem. So hopefully you could follow that. If not, you can just rewind the video and watch it again. And yeah, I give you all of this code, and I'll just post this. I'll just post this MATLAB file for you if you'd like on Canvas as well, so you can check it out a little bit closer if there's anything you'd like to see of how we do it.